Today I'm going to talk about a continuous uniform distribution. Last year when you were doing S1, you met a discrete uniform distribution. A common example of that is the normal six-sided die, where the probability of any one number is a sixth. It's constant. It's uniform, a uniform discrete distribution. Well, let's now try and take the same sort of ideas over to a continuous distribution. Let's suppose that buses stop regularly at a bus stop once every 12 minutes. Not a bus stop in Bangkok. You arrive at the bus stop at some random time. You will have to wait for any length of time between 0 and 12 minutes. No one time is any more or any less likely than another time. All times have got the same chance. This is an example of a continuous uniform probability distribution. The probability density function will be constant. That means that the graph will be a horizontal straight line. Well, let's have a look at a general case of this. Continuous uniform distribution. Firstly, we normally write this as U, square brackets, AB. U is reserved for continuous uniform distribution. We never use it to describe a discrete one. A is always the lower value of the two, the starting point, and B, the higher value. So there is the probability density function for a continuous uniform distribution. What number am I going to put on the vertical axis here? What is the height of this rectangle going to be? Well, you should remember that the area under the graph is 1. The width from A to B is B minus A, and therefore the height is going to be f of x, little f of x, and that is going to be 1 over B minus A. So the number I'm going to put on the axis is 1 over B minus A. What about the mean? What can we say about the mean of this probability density function? Well, I hope you've all spotted that because of the symmetry, the mean must be in the middle. So the expected mean, which we often call mu, is in the middle. That's B plus A divided by 2. We could work this out, the integral of x fx dx between A and B, and you would get exactly the same thing. You would get B plus A upon 2. Well, what about the variance? We can't just spot that. If we're going to look for the variance, then we need to use the formula. Well, there are two formulae. There's the integral of x squared fx minus mu squared, and there's also the integral of x minus mu squared fx dx. That latter one just happens to give me some nice algebra. So let's do the integral from A to B of x minus mu. Mu, I'm just going to write as that for the moment. It's B plus A over 2 squared fx dx. Fx is 1 over B minus A. So this isn't really very much that I'm doing at the moment. X minus mu squared dx. Let's make that 2 look like a 2. If I integrate x minus mu squared, then I'm going to get 1 over 3 x minus mu cubed. Just differentiate there to make sure I'm right. Yes. From A to B. Now this is where the advantage of using this formula comes in. I've got 1 over 3 B minus A. Now in the bracket I've got putting B in, B minus mu. And this is B minus mu is B plus A over 2 cubed. Subtract and put A in, we get A minus B plus A over 2 cubed. It's not as nasty as it looks. It's actually very nice. Inside the first bracket, I've got B minus B over 2. That's B over 2 minus A over 2. So my first bracket is just B minus A over 2 all cubed. My second bracket, I've got A, and then at the end of it, I've got minus A over 2. A minus A over 2 is A over 2 minus B over 2, all cubed. Okay, that's beginning to look rather nice. I've got 2 cubed on the bottom of each of these. 2 cubed there, 2 cubed there. 2 cubed is 8. Let's bring it outside. 8 times 3 is 24. Inside, there's a nice, clever little dodge. I've got minus A minus B cubed. Remember, we've taken the 2 out. Minus A minus B cubed. If you think carefully, that is exactly the same as plus B minus A cubed. Because the power is odd, the minus can actually slide in. Now we have a nice bonus. We have 2b minus a cubed over 24b minus a, and that gives us that the variance of x, cancel a b minus a squared, cancel a 2 over 12, which is a rather nice little formula. What about the median? What can you tell me about the median? Well, the median is in the middle, and the median will divide the area in this square, or this rectangle, into 2 equal parts. And so we don't have to do much work. The median is going to be in the middle. Woohoo, I want the other color. And therefore my median, Q2, is going to be a half of B plus A. In this case, it's equal to the expected mean. So that was the median. What about the cumulative frequency? I said frequency, I meant probability. What about the cumulative probability? What does the cumulative probability mean? It means the probability that x is less than some number big X. That is my cumulative probability. So let's put x on the graph, and then it should be pretty obvious to anybody what's going on. If we put x on the graph, let me use this way of doing it. The probability that I am less than or equal to x, or less than x, doesn't matter which, is going to be the area A, which is just x minus A is the width, times the height, 1 over B minus A, which is x minus A divided by B minus A. I hope nobody is tempted to learn that as a formula. It's just plain, honest common sense. You can find all this and more in your textbook, S2, on pages 68 to 76.